welcome to all. See, lastly, earlier classes, first we consider a single block on horizontal plane, then single block on inclined plane. So many questions. See, today is question number 55. And last few classes, question number, 49, 50, 51, 52, 53, 54. All these questions are two blocks placed here on the same side, on the inclined plane. Then, I don't remember exactly how order. One question, how much force is required to prevent it from sliding down? Same, 50 also. How much force is required to prevent from sliding down? One of the question, force here, see, that is this way. Other one is force here. When force is here, you can't put a cable here. 51, 52. How much force is required to slide it down? See, last time to prevent it slide, now slide down. One question here force, one question here force. Here force means tension, say pull. It can be cable. But when it is here, this should be a rod. 53, 54. What force is required to move the system up the plane? Once here and once here. When it is here, you can put a cable here. But when it is here, you can't put a cable. These are all the questions we solved in the last classes. Now, I will continue for 55 and 56 today. Tomorrow, next class, 56, 57, 58. With that one, the connected bodies are going to be over. If any other tricky question given, since you have got this much knowledge, you can solve. Or maybe, if I find any question is required, later I will go for addition. See, I told everywhere, every chapter, if I feel any questions are required by seeing a question paper or anywhere if I find it, I will go for additional questions. Okay, now, what I will do is here, make a note here. This is not two blocks on the same plane. There are two inclined planes here, see. One block here, connected by a cable. Now rod is not possible, see. Connected by a cable. This is a cable. I'll put a red color. See. Connected by a cable. I show the cable by a red color. See. Connected by a cable. See, cable. This is the cable. See, it goes this way, parallel to the plane. And it goes here. Now, see, cable means it won't stand here. This is a smooth pulley. See what I told? Smooth pulley means it passes over a smooth pulley. In the question given smooth pulley, I will explain for you. That is, a pulley is there. See, you know, in some time from the well, if you want to draw water, the rope will pass over a pulley. You know what is pulley? It passes here. Now, question number 55 is, see here, the person who said the question, what he made a stiff angle here, less angle here. Therefore, if the force is not there, surely, see, this will slide down. That cannot slide down because lesser angle and also high force here and less friction here. So, this block A will slide down. He thinks that way, slide down. When it slides down, this will move up. Now, question is, what force is required, P, to prevent it from sliding down? Which one? Force you apply to here to prevent block A from sliding down. See, block A, find the value of P which just prevents. Just prevents means make a note on the verge of what? On the verge of sliding. I told you, just prevents means on the verge of sliding. Or, right, once again, they can ask you minimum value of P to prevent the block A from sliding down. So all these cases, I told class after class, limiting friction will come. Now you should write it. All those statements you should write. If R is a normal reaction, limiting frictional force is mu into R. That all I won't waste time now. Statements all you have to write. Okay, now, see here. This is given in the question is given by, see, giving word is very difficult. Okay, this is a question. This question is, see, P this way to prevent block A. See, you can see here, this block A most probably start sliding down. So, this has to be a force applied here will prevent the block A from sliding down. Okay, let T be the tension in the cable, which remains constant. Now tension in the cable. Now do one thing, one very important note. which remains constant because it passes over a smooth pulley. See, I told smooth pulley. There is another language, either they can use smooth pulley, make a note here, note, or they can tell smooth hinge, or they can give frictionless pulley. Smooth means frictionless pulley, or they can give frictionless hinge. All are same. Frictionless hinge. Anything given, same meaning. They can call it, it should be a smooth. If it is rough, you cannot calculate. It will become statically indeterminate. Okay. Now, smooth, see, this is smooth pulley. They can call either smooth pulley or smooth hinge or frictionless. Smooth means frictionless. Frictionless pulley or frictionless hinge. This question I gave smooth pulley. When I go to next question, I will change it over to frictionless hinge. Something I will make here. All are same meaning. There is a statement, principle is there. Whenever you write here, note, right here. Whenever a cable or rope or string or wire passes over a smooth pulley or frictionless pulley or smooth hinge or frictionless hinge, the tension in the cable remains constant. Make a note. So I written here, see, let T be the tension in the cable. Then, which remains constant because it passes over a smooth pulley. Now I won't repeat once again now. If tension is here, now do one thing. To understand correctly, see, you write all these ones. It is better you write this sketch once again. Write this sketch once again, and then show the tension in the cable. See, I told tension is always like this. See, tension will pull. If this is T, this also T. See, because this cable passes over a smooth pulley, tension is constant. Now I will not explain once again. So in any question on friction chapter in future, if they give the cable passes over a smooth pulley or frictionless pulley or smooth hinge or frictionless hinge, then tension in the cable remains constant. Means if you write T here, same T here, you show this T here. Okay. Then first make this much. Now, very, very important observation. What they want, see, you should write all I am dictating, you should write here. If you want thoroughly understand, see, write. What they want value of P which just prevents the block from slide. Which one? This P which just prevents the block from block. Which one? This block, not that block. See, when this block comes down, by applying a force here, see, by applying it this way, that block will be lifted. So, what force P is required here to prevent the block A from sliding down? Or imagine if a vehicle is this way, see, in a road, one steep road, one flat road, a vehicle is parked here, a cable passes here or a smooth hinge. Then, if you want to prevent it from sliding, someone has to apply a force like this so that it will prevent. Okay, now we require force P. Now, very, very important. Limiting frictional, I won't waste time. See, I put here FF limit for A, FF limit for B. This all I want to explain. But direction very important. See now, make a note. See, we have to find the value of P when the block A is, see, right here. We have to find the value of P when block A is on the verge of sliding down. Therefore, see, when it is sliding down, when you consider block A, friction is up. See here, when I consider block A, friction is up. Okay. Now, next, and very important, when you apply a force here, when block A is on the verge of sliding down, what about block B? It won't slide down. See, when this block is on the verge of sliding down, that block B, right here, the block B will be on the verge of moving up the plane. See, it will try to move up the plane. So that's why, see here, friction is like this. Or common sense, see here, when you apply a force here, that block See, we are applying a force to prevent the block A from sliding down. So now your P, if you remove P, block A will, you remember that way. If you remove P, what will happen? Block A will slide down. So friction is this way. When block A slides down, block B will move up, see, this way. Therefore, friction for B is reversed, like this. This is very, very important. Make a note. Okay, that's all. Now, there is nothing. See, there are two inclined planes are there. First, now write as usual statement that RA with a normal reaction, RB with a normal reaction. Frictional force limiting here equal to 0.25 RA, friction here is 0.3 RB. T is same. Now 60 degrees, 25 degrees. Okay, now first consider equilibrium of block A. Only block A. See, only block A. Put the sketch. Weight acting down of 6 kilonewton. This angle is 60 degrees. Then, see, I told you when it is sliding down, what friction is this way. How much? FF limit for A is 0.25 into RA and tension T. This is the way. So now, take this as XX, this as YY. See, I told you, whenever inclined plane is there, along the plane we will take XX, perpendicular plane YY. Provided there is only one inclined plane. But someone will tell, sir, there are two inclined planes. No problem. Both inclined planes we are separately considering. At a time, if only one inclined plane is there, you take XX along the plane. See here, XX along the plane, YY perpendicular. But at a time, if two inclined planes are there, it will come for wedge friction. See, when you go to wedge friction later, some question will come there, see this way, and then this way it will come. One inclined plane here. Oh, now do one thing. Now you cannot take, now you as usual take XX horizontal, YY vertical. At that time I will tell you. So whenever only one inclined plane is there at a time, you take XX along the plane, YY perpendicular. So if it is 60, this is 30, see, cos, sine. If I explain further, someone should walk out and tell you are wasting time. Okay. Sigma Fy0. This way positive. Plus RA, I wrote here, minus 6 sine 30 equal to 0, you get the value of RA. Sigma Fx0, you take upward this way, see, right side, this way positive, right side positive. Plus T, plus 0.25 RA, then this is not there, minus 6 cos 30 equal to 0. RA you got it, substitute RA, now you should do it. Now I won't waste time because there is no space to write also here. Now someone will tell how to substitute. Don't substitute, leave the question. You get the value of T. Okay. Now T came. Now consider equilibrium of block B. See here. Don't see that. Block B. Inclined plane is like this. Now you take, this is XX, this is YY. See, XX here, YY here, perpendicular. Okay. Start. Weight acting down of 3 kilonewton. Angle is 25 degrees. If this is 25, this is 65 degrees with the XX. I told 1000 times. If you want cos along XX, sine along YY, angle should be with the XX. Then normal reaction RB. Then this force P is along the plane. And tension T, this tension, see, tension T is like this. Tension T like this, but by this time, you know the tension. So enter that answer. Over question. Sigma Fy0. See, you take this way positive. See, this way positive. Plus RB minus 3 sine 65 equal to 0. You get RB. Sigma Fx0, take this way. See, this way. Right side going down. Your choice. You take this way positive. See, usually right side. Actually, it is not right side. It is inclined. Somewhat this way, right side going down. See. If you take this way, plus P minus 4.446, then plus 0.3 RB. See, friction is like this, I told you, because this is going up, plus 0.3 RB, then plus 3 cos 65 equal to 0. Substitute whatever RB you got, you will get the value of P. So when you apply a force of 2.362 kilonewton, this block A is on the verge of sliding down. So to prevent that block from sliding, you require at least a force of 2.362 kilonewton. Okay, over. Now, next question, what I will do is, see, question number 56. I won't save the time. Same question I will solve. Same question, but one change I will make. Same way question. See, now, one change I will make just to understand. See, this P is in the question. See, in the question nothing given. T we are marking later. See, I told you don't mark T in the beginning. In the question they are not giving any T. This way. See, now, see. This way force. Inclined force I will give you. Inclined force which makes an angle of, say, 10 degree with what? This plane. Question is, two blocks A and B of same weight, 6 kilonewton, 3 kilonewton, connected by a cable which passes over, I'll change the language, passes over a frictionless hinge. See, you can write last time you write here. This is last time you write here. This is smooth pulley, frictionless hinge. Both are same meaning. So this time you write here, later when you solve, it is frictionless hinge as shown in figure. Okay. Find the value of P which, find the, not value of P, I will put here. Find the least value of P, for, see, for moving block A, for moving block A up the plane. That is, this last time they want this P to prevent it from sliding. Now they want, see, when you apply one particular force, that is going to come down. You just to manage. Suppose you have to move up, you have to put extra force now. Further you pull. If you further and further pull, finally this will start moving up. So this is today's two questions. Next class what I will do is, I will make a steep angle here, small angle here, and P I will apply to block A. Block A or 1 and 2. One question to prevent that block from sliding down. Next question to that block to move up. That is next class, question number 56, 57. Okay, now, 1 minute, I will change the statement here. Values will change. I will solve first to save the time. Okay, 1 minute. In the question, that P looks like horizontal. It is not P horizontal. See, it is inclined only with respect to the plane. It is, see, this way. P, they told this angle is 10 degrees. No space here, 10 degrees. Okay. 10 degrees. Okay, now, once again, same question. I told about, see, now you are right. Now, let tension. Once again, put the sketch. At that time, this time, show tension. See? Now, right here, this is smooth pulley. Show tension here. Tension T. If this is T, this is also T. Write it here. Then, right, passes over what I told. Whatever statement given. Frictionless hinge. Frictionless hinge. Now, very, very important. What they want is, right here, they want to find the value of P. See, find the value, least value of P for moving the block A up the plane. Last time, that block they want to prevent from sliding down. This time, they want to move up the plane. Very careful. That's why important. Now you have to apply a force P so that block A will move up the plane. So therefore, right here, block A will move up the plane. when block A moves up the plane, friction will come down. See, last time it was about to slide down, friction was up. But now this time it is moving up the plane, so friction is down. And for block B, see last time, when this is sliding down, this is on the verge of moving up. But when it is moving up, block B is on the verge of going down. See, when you apply force here, when that block goes up, this block had to come down. Therefore, this friction is reversed here. Last time it was this way. Now see, I reversed it. When it goes down here, friction is up. See, last time this friction was up, this friction was down. But this time, this friction is down, that friction up, or common sense. See, when that block A is going down, block B will go up. So last time, block A goes down, friction up. Block B moves up, friction down. This time not that way. You pull it so that block A goes up, friction is down. Block B comes down, friction is up. That much is, you have to make a note. Okay, now solve here. First, consider equilibrium of block A. Once again, same thing, no changes. See, sigma Fy0 this way. What happened? Plus Ra minus 6 sine 30 0. Ra will come same. But sigma Fx0, see, plus T, last time it was what? Plus 0.25 Ra. Now it is minus 0.25 Ra, minus 6 cos 0. So T will come. Now it will come more because when you want to move the block up, heavy effort required, tension increases now. See, it came 5.59946 kilonewton. Now consider equilibrium of block B. See here, block B. Enter the tension, 5.946. Force P is, see, this is x-axis. It makes angle 10 degrees. So when you resolve here, this is cos, this is sine. If you take 10 degree, this is thousands of time told. 25 degree, 65 degree, sine cos is known for you. Friction is this way. So now what will happen is direct answer will not come. See, direct answer will not come. I'll write here. Space is there? Yes. Okay, see. I'll write here for you. Okay, start. This also I can remove. Okay. I want more space. Okay, see, for this one more space. Sigma Fy0, take this way positive, see, this way positive. Plus RB minus, what one thing, see, unknown is P. You start from P first because now P also is there. See here, P is going this way, this component, plus P sine 10, see, plus P sine 10, plus RB minus 3 sine 65 equal to 0. You call equation number 1. You simplify it. Then sigma Fx0. Take this way positive. See, this way positive. So plus P cos 10 plus P cos 10. If they give pure horizontal, if they give last time P along the plane, this will not come. RB directly will come. But now simultaneous equation, plus P cos 10 and then see minus 0.3 RB, see, plus P cos 10 minus 0.3 RB, then minus 5.946, and also see, we are taking this way positive, plus how much? Plus 3, where is it? Cos, it's, see, plus 3 cos 65 equal to 0. This you call equation number 2. Correct answer? I'll check once again. Plus P cos 10, see, sigma Fx this way positive, plus P cos 10 minus 0.3 RB minus 5.946 plus 3 cos 65 is 0. Solving 1 and 2, you get the value of P. But this time your P should come more than last time. Last time, see, you want to prevent from sliding. This time you want to lift up. See, moving up the plane has got more effort. So you will get the value of P. Okay, solve. If you go for the equation mode, see now how I am solving. Mode, shift alpha, mode, shift alpha A. Simultaneous equation. Unknowns are 2. Okay. Sin 10. Next one is 1. This I should take that side. 3 into sin 65. Okay. Equation 1 over equation 2. Cos 10 minus 0.3. Then this will go that side. 5.946 minus 3 cos 65 over 5.298 is my answer. If by chance wrong, you correct it. See, plus 5.298 kilonewton required. So if you apply a force of, last time I don't remember, it was some 2 point something I think. When you apply, see, last time was just to prevent it from sliding down. This time you want to lift it up, so you apply more force. Okay. By chance, if this answer is wrong because of my calculator problem, you correct it. Don't make an issue. Once I write the simultaneous equation, my teaching level is over, teaching part is over. These all I should not explain, but usually I give the answer. Okay, this is over. Today I am curtailing the class, 2 questions over, because little more, there are a lot of commitments are there for me. In the morning commitments were there, little late I came. Now next class what I will do is, I won't explain once again, I will tell go back last time. This I will place on a steep surface, see this block. I will place a steep surface. This is a flat surface. One block here, connected by a cable. Now we will apply force P here. One is what force is required to prevent that block. Instead of A and B, I will call 1 and 2. For block 2 from sliding down. Next question, 57 over 58. What force is required to move the block 2 up the plane? So there, you have to first consider block, not block 1. You have to first consider this block, then come to this block. Y means unknown. See here, why this block first? Because you can make out here. Unknowns are what? RA and T. That block unknown. RB, T and P. That's why first block A. Or your unknown is P here means that, see, if they want some unknown here, you consider this block first. If the unknown is here, consider that block first. Okay, this is all told. Thoroughly study all the questions. See, these are all not structural design questions. These are all examination oriented questions, which usually in academic questions, very popular, such questions. Engineering mechanics examination they give, and also competitive examinations. Structural knowledge point of view, now nothing more required except common sense is called ladder friction. See, when you put a ladder here, see, when you put a ladder here, when the stability of the ladder, that is little practical oriented. Otherwise, next you are going for some special questions after this one. Then wedge friction, only academic point of view. But I decided to systematically complete. Actually, I am waiting for this chapter to be over so that I can start powerful subject of strength of materials. But I do not want to leave it halfway through. See? So another 10, 11 classes will be there for friction. So those who want, they will study. Otherwise, will not study. But initially, some questions important for practical also. This I told. Okay. Thank you. We'll meet in the next class.